Welcome back, everyone. This is part 3 of lesson 1, the limits unit. So we are going to discuss the limits and the continuity of a function. So below here is the graph of function f of x in red. And as you can see, this function is made of various pieces, okay, because you have to lift your pencil in order to follow the curve. So our job in here is to find out what the value of the function will be at the indicated point. So we are given some values, a equals 1, -1, -3. We want to find out the value of the function at the particular points and the value of the limit at the same points. So as you can see here, at x equals 4, when a equals 4, here is x equals 4, the value of the function at 4 is 5. Just look at the graph. Now, if you approach number 4 from the left and the right side, you notice that the values of y will be about 5. Excuse me. So the function is continuous actually at x equals 4. There is no interruption. So we're going to say the function and its limit equal each other. The function is continuous. Now we're going to take a look at -1. So at x equals -1, which is right here, the value of the function is 3. So that's a fill dot. Why can't we consider this? It's an empty circle, okay? It's not the value of the function. So we're going to say that f at -1 will be 3. Now, when we talk about the limit of a function at x equals -1, we're not talking about simply the value of the function at -1, but we're talking about the estimated value of the function around -1, because that's what limit does. It gives us an estimation of the value of the function around a point, okay? So not the exact value of it. So in this case, we're going to say that when you approach -1 from the left and -1 from the right, you notice that the values of y will approach 1. So we're going to say that the limit is 1. So as you see here, the value of the function at -1 is different than the value of the limit. So when this happens, then the function is discontinuous at x equals -1, so at this specific point. So in a similar way, we can say that here we have the value of the function at 4 was the same as the value of the limit at 4, so both values were equal to 5. So in this case, we say that f of a equals the limit as x approaches a of f of x. So we're going to say that the function is continuous at x equals 5. All right? So just to write them in the same format. So f at -1 is different than the limit as x approaches -1 of f of x, because one of them has a value of 3, the other a value of 1. So we say that the function is discontinuous at -1. Now we're going to take a look at one last point. So at x equals -3. So if you ask the value of a function at -3, you have to find an existing point on the graph at -3. So I will draw a perpendicular because I see that I have function around -3. I have function either above or below the x-axis. So if I go and hit the lower part of the graph, I see that I'm not hitting a point on the graph because that's an empty circle. So that's not the value of the function. So I'm going to hit the point above or in the upper part of the function, and I see that the value of the function is 4. So we're going to say that f of negative 3 is 4. Now, when it comes to the limit, we want the behavior as we approach each side of this particular x value. So we are approaching negative 3 from the left end of it, or left side of it. So here's negative 3 from the left side of it. The graph will be this one, okay? So the values of y will approach number 4. So we're going to say that the limit as x approaches negative 3 from the left would equal about 4. Now we're going to take a look at the limit as x approaches negative 3 from the right side of it. Still talking about f of x. So we have to write this. So when you approach negative 3 from the right side of it, there is no graph in this area, right? But there is graph on the lower part or below the x-axis. So you can see that as you get closer to negative 3, the function is approaching negative 2. So we're going to say the value of the limit is negative 2. Now remember that when the limit of a function at a point has the left and the right end, not agreeing to each other because one is 4, one is negative 2, we say that the limit does not exist. And when the limit doesn't exist, it's definitely a discontinuous function. Okay? Because remember that for a function to be continuous, not only the limit has to exist, but it must also equal the value of the function. When the limit doesn't exist, we have nothing to compare with the value of the function. All right? So here I listed some of the properties of limits, the main properties of limits actually. They're fairly easy to actually understand, kind of make sense, they're common sense. So as x approaches a of f of x, and x approaches a of g of x, suppose that these are the limits of two different functions at a. So if they both exist, then we're going to say that the limit of the sum of the two functions will be equal to the sum of their limits. Okay? In a similar way, the limit of the difference of the two functions would equal the difference of the limits. If we have the limit of a constant times a function, that would be equal to a constant times the limit of the function. So you can take the constant out. If we have the limit of the product of two functions, that would equal the product of the limits. Same thing with the quotient. So the limit of the quotient of a function equals the quotient of the limit. Again, the denominator cannot equal 0. And the same thing with the power. We can take the power out. So the limit of f of x to the power of n as x approaches a would be equal to the limit of f of x as x approaches a to the power of n, where n is a positive integer. Because with a negative integer, we talk about fractions, so there's different rules. The same thing with the powers or with the roots. Now remember, roots are nothing but rational exponents or rational powers, so the same rule applies in here. Okay. And here you have more practice questions about limits. I wrote a couple of, or a list of strategies here. It's something you can create on your own, and that's what we're going to try to do in the upcoming lessons. So you create a list of strategies that you learn on your own. And here is your practice. And I hope that everything made sense, and I hope that you found the lesson entertaining and easy and enlightening in some ways. So bye for now. See you again soon.